Hello everyone, welcome to my channel TechXeno. In this video, we are going to learn the difference between classification and regression in supervised learning. This is one of the most important uh, differences in machine learning subject. So let's get started. First of all, we have to know what are the basic difference between classification and regression. Both are the types of supervised learning. So what classification says, it is supervised learning task used to predict a discrete level or category for given input data. Let's suppose we have some input data, like we have to check that given input like email is a scam or not spam. So then it means we have to categorize the email into the category, right? So that is called classification. Like simply yes or no, divide the input in yes or no. Okay. In regression, what is happening? In regression, it is also supervised learning task which is used to predict a continuous numeric value for a given input data. Like what we say, if we want to predict the house price according to the square feet, so that is like that we have to predict a numeric value. It can't be like yes or no, yeah, true, false, something. Not like that. It should have some value, right? So I guess basic difference between classification and regression is clear. So let's talk about types of output. Types of output means output variable is categorical in classification. Finite sets of classes we will have. In regression, output variable is continuous, real valued, like some value we have, like we can plot in the graph. Um, Objectives. What are the objectives of classification? To assign input data to predefined classes based on learned patterns. We have some test data to categorize the data we in spam. Let's see, we have let's take the example of email classification. So email can be spam or not spam. So in test data we have defined the classes of that data, that is some email is spam, some is not spam. Okay, so if we get new input data, so on the basis of that patterns, we can predict what is the class of that new input. Okay. So similarly in regression, what we have to predict? We have to predict a real value quantity based on the input features. We have to, like, we can't say okay, house price will be yes or no. No, can't. We have to like give the almost accurate value for that in numbers. So what are the examples in classification we can have? Email classification, in medical diagnosis, disease classification, sentiment, positive, negative. In regression, predicting house prices, estimating temperature, predicting sales or salary. Okay. So what are the algorithms used in classification? Are decision tree, ID3 algorithm, KNN, known nearest neighbor, naive Bayes, logistic regression, SVM. So SVM have both classification and regression mode, but we are talking about only classification in okay. Then in regression we have linear regression, polynomial regression, support vector regression. What is the nature of boundary? Clear decision boundaries that separate different classes. Let's say we have some male here, we have some male here. Okay, so this line creates a proper boundary between these. Let's see, this is positive and this is negative. So it creates decision boundaries that separates different classes. Both are different classes, let's say positive, negative, or true, false, spam, not spam, anything. So this line creates a clear boundaries between that. Okay. So this is the example of classification. Mm, hmm. Fits a baseline or curve to represent the relationship. Let's say we have different points. So what will be the best fit suited line here? Okay, let's say this is the best fit suited line where that line is passed to the most of the points. So this will be called as best fit line, or if we have some curve, polynomial curve, let's say polynomial curve, so that will be called as best fit curve. Okay. So with this we can show the relationship between two variables. In this x axis we will take independent variable, in y axis we will take dependent variable. Evaluation matrices, how we like evaluate the model in the basis of accuracy or precision, recall, F1 score, confusion matrix. So this we will learn in future videos. Or in regression we have mean square error, root mean square. So these are the evaluation matrices that we can measure the efficiency of the algorithm. Output interpretation means output is a class level, example cat, dog. In regression, output is a numerical prediction. Let's say we have predicted the how in 200 square feet house have the price of 3,25,000. We are predicting some numeric value, right here. But we are here in classification we are predicting some class. In visualization means data points are divided by boundaries separating categories. In regression, data points are fitted by a regression line or curve. We have this, can we say, as regression line. Real world use, what are the real world use cases of classification? Email spam detection, credit card fraud detection, medical diagnosis, or in regression predicting stock prices, temperature forecasting, growth prediction, predicting house prices. So these are the examples of regression. I guess it is pretty much clear difference between regression and classification. You can take the screenshot from here. So I guess that's it for this video. We'll meet in the next video. Thank you.